The title of this lesson is I'm Sorry. The power rule. The derivative of x raised to the n. We don't care what n is, it's just some number. Could be the third, could be the fifth, could be the eighth, whatever. We're going to find out what the derivative of that is. What you're going to find out is, once we know this one, the coefficient rule, and the sum and difference rule, derivatives are going to become a lot easier. This is the shortcut. We just got to prove it first. So, if I take f of x equals x to the n, and I have to take the derivative of it. So I'm going to use the definition of derivative, x plus h raised to the n minus x to the n. So f of x plus h minus f of x all over h. The limit as h approaches 0. Remember, that's just slope formula. Change in the y coordinates over the change in the x coordinates. Well, if I'm doing this here, x to the n, well, if n is 0, that's just going to be 1. Easy. If it's the first, x plus h to the first, just x plus h. X plus h to the second is just x squared plus 2xh plus h squared. X plus h to the third. You get this. What you'll notice is, if I'm doing this, and then I have to subtract x to the n, the first one's always going to fall away, isn't it? So x plus h squared minus x squared, that one always falls away. Minus x cubed, that one falls away. Minus x to the fourth, that one falls away. So what we end up having then is you'll notice that each time the power right here is right in front of the second term. Because the first one got killed by subtracting f of x. So we're going to have n x to the n minus 1 times h plus, and then we get some other numbers here. But you'll notice that when we divide it by h here, all of these other numbers, whatever this number is right here, x to the n minus 2, there's some number here, I don't know what it is, we'll call it k. And then we have h to the second. When I actually cancel out the h's here, if I factor an h out of this whole thing, I get n x to the n minus 1 plus, well, whatever that other number is, k, x to the n minus 2, h, plus whatever the next one was. Like here was 3, here was h to the third, or 4x h to the third. So some other number, we don't know what it is. We'll call it m x to the n minus 3 h squared, and that just keeps going. When these cancel out here, then I finally make h 0 and make h approach 0. That's going to be 0 essentially. That's got a 0 on it, so I don't really care about what that is because I'm multiplying it by 0. So all those cancel out, and I'm just going to get n x to the n minus 1. So if we looked at this for, let's say, x to the fourth, if all this right here is too many letters for you, which I understand. If I did x to the fourth, f of x equals x to the fourth. So I'll get the limit as h approaches 0 for x plus h to the fourth minus x to the fourth all over h. Once again, you'll know this is actually Pascal's triangle. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. So we'll get x to the fourth plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the fourth. That's all this minus x to the fourth all over h. Well, that goes away. To the limit as h approaches 0. 4x cubed. I'm going to go ahead and factor in h here too. 4x cubed, factor out that h, plus 6x squared, factor out one of those, so that's still h, plus 4x h squared plus h cubed. So I cancel those out. I factor an h out of all of those. That h cancels. So I get the limit as h approaches 0 for 4x cubed plus 6xh plus 4xh squared plus h cubed. Hey, guess what? If I make h approach 0, 6 times anything times x times 0 is basically going to be 0 plus 0 plus 0. 4x cubed. So x to the n, the derivative of x to the n is always, bring it down, x to the n minus 1. That's the shortcut. This is the long way. So what if I said f of x is equal to x to the 10th power? Do you want to take x plus h raised to the 10th power? No, you don't. So how do we derive it? The 10 is the exponent, right there. I'm going to bring it down in front. 10 times x to the n minus 1. Well, 10 minus 1 is 9. So it's 10 x to the 9th. Sorry. 10x to the 9th. What would... Completely different problem here. F of x is... Oh, let's do an easy one. X to the second. Well, I'm going to bring that down in front. So that's going to be 2. X. 2 minus 1 is 1. Boom. Yeah, that's what happens. It's a lot easier once you know the shortcut. I'm sorry. You had to know where it came from, though. You had to know that it comes from the slope formula, and there's all this great math behind it, but once you figure out the pattern, it's a whole lot easier. What is... Let's see here. If f of x is... x to the 73rd, f prime of x, 73 x raised to the 72nd power. Just that easy. Yeah, you're groaning now. I can hear you. All right. Now, I actually got these backwards. Sorry. The coefficient rule is actually down here. So let's look at the coefficient rule, shall we? If I take some number times a function, I got to take the derivative of it. For example, if f of x is equal to 4x to the 6th, we can actually just derive this second part and then just multiply it by 4. How do I know? Well, let's make sure it works according to the limit definition of derivative. F of x plus h, so I'm just plugging that in there, minus the constant times f of x all over h. I can factor out the constant. F of x plus h minus f of x all over h. I can actually factor it out of the entire limit. So the limit, so some constant, whatever that is, in this case 4, times the limit as h approaches 0 for f of x plus h minus f of x all over h. Man, that's horrible. Sorry about that. Hey, guess what? That right there, that's just the definition of f prime. So how does this apply to us? Let's look at this one right here. All I got to do, I'm not even going to do the limit definition of derivative. I'm going to do the shortcut now. I'm going to just shove the 4 to the front. I'm going to derive x to the 6th. The derivative of x to the 6th is going to be 6x to the 5th. Once again, that's the exponent. I bring it down in front. I subtract 1 from it. That's the power rule. So what is f prime of x? 4 times 6, x to the 5th, so 24 x to the 5th. Boom, done. Don't have to do the great big long equation anymore. That's it. That's the coefficient rule. If you got a coefficient in front, just shove it to the front and leave it. We'll deal with it once we've taken the derivative of the actual function. The sum and difference rule, which is up here. If I've got a function plus the function, I got to take the derivative of it. Or it could be minus, doesn't matter. Well, what's the derivative of it going to be? F of x plus h plus g of x plus h minus f of x plus g of x all over h. The limit as h approaches 0. That's the formal definition of a derivative. So, I'm just going to rearrange this. Limit as h approaches 0 for f of x plus h minus f of x plus, scoot this one over, g of x plus h minus g of x. I just distribute the negative right there. This is all over h. Well, guess what? I'm going to rearrange it. F of x plus h minus f of x all over h plus the limit as h approaches 0 for g of x plus h minus g of x all over h. Hey, guess what? This right here, that's f prime of x. This right here, that's a definition of the derivative of g of x. That's g prime of x. They were added in between. So instead of having to do it the long way, I can just take the derivative of the first function and the derivative of the second function. How does this help us? Examples. 8x squared plus 9x minus 2. I've got a big old long function. Do I have to use the great big long definition of a derivative? No. Heck no. Save yourself some time. The derivative of 8x squared. Well, according to the coefficient rule, I can just take the derivative of x squared. Derivative of the x squared right here, it's going to be 2x. Bring the 2 down in front. 2 minus 1 is just 1. 9x. Well, we can do it the long way if we want to. We can say 9, just keep that up front, Remember that this is x to the first. Well, bring the 1 down in front. 1x. 1 minus 1 is 0. And then minus 2. Well, okay, hang on here. Derivative of 2. Derivative of any constant. Well, a constant function, 1, 2. If here's our line, what's the slope of that line? It's 0. Alright. But what is x raised to the 0? It's just 1. Because the slope of 9x slope is just 9. So what's our derivative here? G prime of x is 16x plus 9. That's it. Down here, 6x to the 9th. Gotta take the derivative of this. That part's going to be easy. I'll get to that in a moment. This, though, 5 square root of x. I want to use the power rule. What is square root of x? It's 5x to the 1/2. Alright, so if I got to derive this right here, I'm going to get 6 times derivative of x to the 9th is going to be 9x to the 8th. That one's done. 5x to the 1/2. Well, I got to bring the power down in front. It doesn't matter that it's a fraction. We can still do this. That's what's so great about this. It's going to be 5 times derivative of x to the 1/2 is going to be, well, bring this down in front, 1/2. Got to subtract 1 from 1/2. Well, 1/2 minus 1 is x to the negative 1/2. So h prime of x is going to be, you can actually leave it just like this if you want to. If it's a free response question, that's good. Let's simplify it just for funsies though. 9 times 6 is 54, x to the 8th, minus, well, that's going to be 5/2, x to the negative 1/2. Oh, we don't like negative exponents. Actually, it doesn't bother us. But let's say it's a multiple choice question. That's not one of the answers, so it's going to be 54x to the 8th minus 5/2. X to the 1/2 is the same thing as the square root of x on bottom. Boom. Done. This one. Oh, crap, Mr. Kuhne. You're being a jerk now. Yes, I am. 2 divided by the cubic root of x. Well, let's see here. It's on bottom, so that's going to be 2x to the negative 1/3. All right, minus 10 over x to the 4th. Well, that's 10x to the negative 4th. Now I can derive it, because now it's in power form. 2x to the negative 1/3. Well, I'm going to leave the 2 out in front here. The derivative of x to the negative 1/3 is going to be negative 1/3. Because I got to bring the exponent down in front. X. What's negative 1/3 minus 1? Negative 1/3 x to the, that would be negative 4/3. Minus, let's do this one, 10. Bring the exponent down in front, negative 4. X to the, well, what's negative 4 minus 1? Negative 5. You can leave it like this if you want to. That is perfectly acceptable. But just for fun, let's go ahead and clean it up. j prime of x is going to be, now it's going to be negative 2/3 cubic root of x to the 4th minus, oh, two negatives make it positive, 40 x to the negative 5th means it goes on bottom, x to the 5th. Aren't you glad we don't have to do the limit definition of a derivative on these? Now that doesn't mean you can forget it, because here's why. This is a common free response question on the test. Limit as h approaches 0 for x plus h squared minus 2x plus, we'll make it 3x, plus 3h minus x squared minus 3x all over h. What do they want us to do here? Well, this is actually a sneaky way of saying take the derivative. We don't have to use the limit definition of derivative right here. Good Lord, no. What was our original function? Well, you know it's f of x plus h minus f of x all over h. Great. F of x is x squared minus 3x. This is what we have to take the derivative of. F prime of x. This says take the derivative. That's all it says of that function. So the derivative of x squared is going to be 2x. The derivative of negative 3x is just minus 3. Boom. And you're done. All right, now that I've blown your mind, if you need to pause, take a breather, go for it.